security and policy initiatives.
Good morning, everybody. I am Pradeep Gupta. Welcome to you all to today's webinar on the theme Drone Technology and Applications. At the outset, I welcome Lt Gen TSA Narayanan, AVSM, ex-Commandant MCEME, who is the keynote speaker for military drones. Prof SD Gorantiwar, the Director Research and HOD Agriculture Engineering in the prestigious Mahatma Phule Krishi Vidyapeeth Rahuri. It is better known as Rahuri in Ahmednagar, who is the keynote speaker for agriculture drone. Mr. Ajay Sani, distinguished strategic affairs expert. Professor Bimal Roy, who is the person who motivated us to set up this SAPI. We have distinguished veterans here, General Ashok Kumar, and more are joining just now. Before we get to the today's theme, a little about the SAPI and its founders. I am Pradeep Gupta, the founder of SAPI, a technocrat and bureaucrat. I have worked on the shop floor in the arms and ammunition production. Besides, I have worked in the ministries at the senior levels in the Ministries of Defense, External Affairs, Finance and Home, as well as Rashtrapati Bhavan. Another founder is Dr. Mrs. Sangeeta Goyal. She is also an ex-bureaucrat, but postgraduate in MSc in Public Policy and Management from Carnegie Mellon University. She has done PhD also in the same subject from MDI, and her research papers in these subjects are widely acclaimed and included by the American Management Association. Another founder is Lt Tewari. He's the founder CEO of the AI-Watt AI Private Limited, which has some unique AI inventions to its credit. And he's also a pass out of Iowa State University MBA, as well as a graduate in computer science. Another founder is Mr. Sarang Nerkar, who is founder CEO of the InnoSapien Private Limited. And he has few patents also, and he's close associate of the Professor Stevie Mann of the Toronto University, who's better known as father of variable computing. And Sarang is pass out of Toronto University in electrical and electronics engineering. So this is the SAPI. SAPI was founded in October 2021. And it is an acronym for Securities and Policy Initiative, working in the absorption of defense transfer technology, improvement of border management, in the public policy realm, as well as art and culture. We have taken up this task just now. We have been organizing webinar, publishing blogs, articles, as well as participating in some discussions. Our basic motto is to spread knowledge and catalyze it, and also spread it in far and wide. The SAPI has been mentored by few persons, and one of them is already here, Professor Bimal Roy. Another mentor has been Mr. Shekhar Dutt, ex-Defense Secretary and ex-Governor of Chhattisgarh. Mr. Arvind Gupta, currently Director of Vivekananda International Foundation and ex-DG IDSA. He was Deputy NSA too earlier. And Dr. Sivithanu Pillai, the father of BrahMos Missile, founder CEO of the BrahMos Missile Corporation. SAPI had been, since its inception, mainly been in virtual space, but very soon we are going to come in the physical space too, very soon. We envision in the SAPI that to generate knowledge and ideas which may impact, especially on the ground level. This is in this area, there is lack of focus by other think tanks too. So like today's webinar will show it how it is coming up. Coming to today's webinar theme, the drone. I'll just highlight certain aspects of the drone technology, and thereafter why we have picked up this drone. Drone is the successor of the UAVs. UAVs were conceptualized long ago, 60, 70, 80 years ago. And it was an unmanned or uncrewed flying machine used for certain dangerous missions, dirty missions by the militaries. And as the technology advanced in these 6, 7, 8 decades, it has taken a very powerful shape now, and it is having its own role in the mainstream war also. And it is coming of the age with the advent of technology like AI solutions, powerful circuits, better batteries, lighter materials, and all these things. It has its extent has reached, extended to the civilian space also, and it is being used in agriculture. Professor Gorantiwar will share his ideas about that same. And also in logistics, in infrastructure, in so many other fields, commercial also. So we'll see that the drone is going to reach everybody's life, and it will be a big disruptor in the industry functioning, especially in these areas what I mentioned. And very soon we'll see so many other things. Now, why did we choose this field of drone? I just like to mention that this drone technology, if you see, it is not as complicated as making or designing a fighter aircraft or tank or a ship or a nuclear submarine, etc. So it's a low-hanging fruit for us, and we are quite capable in India in making algorithms and software part of it. And in India, due to support of the government and the private industry and the academia and research institutions too, we have been able to, we are in the process rather of indigenizing or making our own design, better design components here. So we'll not be importing. Just now, a lot of these components are imported, but very soon in the future times to come, we'll not be importing these things. Rather, these will be made here locally. So it will be completely indigenous. This is one. Now, there are so many progresses being made in this field. And I'm sure with this pooling of the synergy of the minds of Indians, we'll be able to conceptualize the best of the drones all over the world, and we may be becoming a drone nation very soon. So that's why I picked up this topic, and just like to that this is the beginning, and in times to come, we'll have better, deeper sessions in these specific topics. Now, coming to the main proceedings. I'll just introduce Professor Gorantiwar, who is the keynote speaker for agriculture drone. And after this, he will be speaking on his presentation. Professor Gorantiwar, Sunil Gorantiwar is a professor and HOD of Mahatma Krishi Vidyapeeth, Rahuri, Ahmednagar. It's a very famous, prestigious agriculture university. He's also director of research there. He's MTech from IIT Kharagpur, besides PhD and postdoc from Loughborough University of UK. Besides this, he has authored several research papers which have been widely acclaimed and awarded also. And he's also authored several books in international level as well as national level. He has a lot of technologies to his credit, which is very remarkable. He has developed irrigation scheduling for pomegranate, lime, and bindi, that is ladyfinger, subsurface porous pipe irrigation system for sugarcane, crop coefficient of wheat, gram, kharif sorghum, rabi sorghum, gram, artificial groundwater recharge through percolation tanks. And the most important is that he is running a massive drone center in Rahuri, wherein there are more than 40-50 drones are there with him of various types. He's devising the applications as well as he's doing the pilot training there. So very widely experienced Professor Gorantiwar in this field of drone in agriculture. I request Professor Gorantiwar to start his presentation. Thank you. Thank you.
Thank you very much. Thank you very much for setting the scene properly and also introducing me. I would like to share my presentation, and I hope the time allotted to me is 20 minutes, and I will try to limit myself during this time period. Today's keynote speaker, respected Lieutenant General retired TSA Narayanan sir, and at the same time, founder and co-founders of SAPI, Mr. Pradeep Gupta, Dr. Sangeeta Goel, Sarang Nerkar, Lt Tiwari, and all other dignitaries and participants who have joined for this webinar on drone technology and applications. And my topic is drones for agricultural applications. And very good morning to all those who have joined. The focus of my presentation is something like that. I have divided my presentation into 7 topics, starting with the potentials of using drone in agriculture, benefits of using drones in agriculture spraying. And as we know that drone is the newer technology and there will be certain issues and challenges, so that I will discuss. Then how to use drones for agricultural spraying. And there are certain standard operating procedures for using drones for agriculture spraying. So I will also try to highlight on this. Then there is one more formidable applications of drone in agriculture, that is the inventory mapping, and also that is with using hyperspectral imaging. Then there are different permissions which are required for using drones in agriculture. I will try to narrate those permissions in brief, and time permitting, I will also try to elaborate what are the future perspective of using drones for agriculture. Potentials of using drones in agriculture. Now, as has already been pointed out by our founders, that's drone is being widely used in various sectors of the development, and agriculture is no exception. Generally, what happens whenever there is advanced technology, this advanced technology is being used in other sectors, say maybe transportation, navigation, or automobile industries, or so on. And agriculture is almost the last sector to adopt this application actually. But in case of drone, we have started application of drones in several sectors, and parallelly, we have started applications of drone in agriculture. This is primarily because of the government encouragement and government initiatives for using drones in agriculture. There is one target which has been set up by the government that maybe in next 10 years, 2 lakhs drones will be used for different operations in agriculture by using drones. I have categorized the application of drones for agriculture in 2 kinds actually. One, we can apply several inputs with the help of drones in agriculture. And another application is we can make the resource inventory and mapping by using drones in agriculture or farming. As far as input applications are concerned, we can use drone for the spraying of nutrients and spraying of insecticides and pesticides, that is the chemicals actually. Nutrients we need to enhance the fertility or productivity of the soil, and chemicals, that is pesticides and insecticide, we need to control the pest and diseases, and in turn to avoid the reduction in the crop yield. So these 2 applications, we have already started working on this. We have prepared the standard operating procedures. The farmers, they are also using the drones for these applications in agriculture for various crops, including sugarcane, pigeon pea, wheat, rice, and certain kind of the fruits and vegetable crop. Then another upcoming application is seeding actually, though it is not properly formalized, but we are in a process of developing certain tools that can be attached to the drones for seeding, that is sowing. Anyhow, we can make these seeding operations in forest and other areas. But as far as the agriculture is concerned, we need to optimize the seed amount, and we have to sow the seed in particular geometry. And for that, we are investigating the appropriate tools to be attached to the drones for this purpose. As far as the spraying is concerned, the tool that is to be attached to the drone is the sprayer and nozzles. So that is already developed actually. And another application is bird scaring. that we already know that in the beginning of the COVID period, the drones have been used to prevent the attack of the locust from our north western boundaries actually. So that we already did, and that we can also do for the general farming as well. So this is as far as the input application is concerned. But at the same time, the drone has formidable application in inventory mapping, and with the help of inventory and mapping by drone, we can use the outputs of the inventory and mapping for various other applications, as I have indicated on the screen. The first application is the crop acreage estimation. Anyway, we can use or we can estimate the crop acreage with the help of remote sensing satellite, but then remote sensing satellite has a certain limitations to be used at the finer scale, and drones based cameras can remove those limitations. So we can have this crop acreage estimation with permissible accuracy with the help of drone mounted cameras. Then second application is identification of the biotic stresses. Biotic stresses in the sense that whenever there is attack of insects, pest and disease on the crop, then we need to identify those attacks or kinds of the pest and diseases well in advance, so that farmers can prepare themselves for taking the curative measures actually. But currently what happens, whenever attack is there and by the time farmer knows, then a lot of damage has already occurred actually. But with the help of drone, we can identify these stresses. At the same time, there is possibility that we can also forecast these stresses well in advance, so that farmer can be in a preparedness. So this is one of the strength of the drones. Second is abiotic stresses as well. Abiotic stresses means that the stresses because of the environmental parameters such as temperature, rainfall, and humidity. As far as the stresses due to temperature is concerned, that is very important because that governs the application of the water or irrigation. And if we know those stresses well in advance, then we can plan or schedule our irrigation, and so that crop gets the water in time and as per the need. We have already started work on both all the three aspects actually: crop acreage estimation, identification of biotic and abiotic stresses. Another is the crop growth monitoring. This crop growth monitoring is required especially for the crop yield estimation. Whenever we grow crop, then there are certain models, or we take certain observations manual, and then we try to estimate the yield. But in case of the drone monitoring, we can monitor the crop growth accurately. This we can do with the help of remote sensing satellite, but then again there are limitations. But with the help of drone, we can select certain areas and we can monitor the growth of the crop, and in turn we can also predict the yield. So this prediction of the yield and also the crop acreage estimation together contribute to the crop yield assessment as well. As we know that crop yield assessment is very important parameter that is required for several government schemes, and with the help of drone that we can do actually. In fact, all these 5 applications we already started working. There are certain universities and institutes we have collaboration, and we have also produced some outputs as well. Then soil characterization is very important but challenging. With the help of the drone-based cameras, we can scan the surface characteristics of the soil, but for soil surface characteristic is not important, so we have to use certain surrogate measures. The studies are going on to use the surface characteristics, in fact, measured by the drone-based camera, and to relate it to other soil properties. Crop insurance, once we know the forecasting of the yield and the crop yield assessment, so this information is useful for crop insurance. And the next is the biomass estimation. So all these are very important for agriculture, for improving the productivity and also for improving the input use efficiency. And drone has a major role to play in all those aspects. Currently, drones are used majorly for the spraying actually, and followed by mapping. The spraying is the subject of heart as far as the farmers are concerned. Farmers, they don't use the drones for mapping directly, but the drones for mapping, they are used by the certain agency, and the output of which is useful anyway to the farmers. But farmers, they are interested to use the drone for the input applications, as I described before, and currently interested in the spraying of the chemicals actually. Just a minute, I will take just one break. Okay, sorry. Then there are several benefits of using drones for agricultural spraying. One is that there is no direct contact with spraying chemicals actually. Means when we use when we use pesticides and chemicals by the conventional spraying, then in that case, the farmers are the human resources, they come in contact with the chemicals, and then there are very harmful effects. But if we use the drones for spraying, nobody can come in contact with the chemicals actually. Another thing is that it has very high field capacity. With the help of one drone, we can cover 20 to 40 acres per day. But to cover those much area with the help of the manual or tractor operations, so we need too many tractors or human resources, and the farmers cannot employ those, those are not available. And then by the time farmers control the pest and disease attack, the crop has already damaged. Then next is the reduction. With the help of drone spraying, we can save 25% of the chemicals. Then it is not only saving the precious chemicals, but at the same time minimizing the hazards to the environments as well. When we use spray the chemicals, then we need water as the filler material, and with the help of the conventional spraying, we need a lot of water, say of the order of 400, 500 liters per acre. But with the help of drone, that water is reduced to just 10 to 20 liters. So there is 90% saving as far as the use of water is concerned. And then it is also low cost, and if properly trained, easy to maintain as well. And it also promotes the local entrepreneurship, because we know that if we take the examples of the tractor in the beginning, 50 years ago, was the innovations as far as the farming is concerned, and there were not many takers for the tractors for agriculture. But you now see the scene, it has developed the local entrepreneurship, and the same thing will happen or is happening for the drones. Drone is the machine and tool, and with the use of drones in rural area, it will also promote the local entrepreneurship. So these are the certain benefits of using drones for agriculture, spraying, and agriculture and spraying in general. But at the same time, there are certain limitations as well, because the drone is the new technology. So whenever the new technology, especially that come in use for the agriculture, then there are several challenges, because agriculture is very complex and heterogeneous system. So it is not just like the industry system, which is governed by the rules, but agriculture is very complex. The first limitation is flight time and range as well, because we have to use the drone in the rural area as far as its applications are concerned. Then its range it could be a problem. Flight time, in the sense that with the current level of the technology and life of the battery, for spraying, the drone can be in an air for about 10 minutes only. And so we have to perform the operations within 10 minutes. Then we have to bring drone down and again change the batteries. And so we have to do all these kind of the things. So currently there is limitation, but now the petrol operated and hybrid drones and some efficient battery systems, they are coming, and maybe this flight time can be increased actually. But anyway, in one flight time of battery, we can cover up to 2-acre area. And so farmers, they are satisfied with this. Life cycle of the battery, that is also currently issue. So with the current level of the technology, the battery time is up to 20 to 30 minutes. Then certain certified formulations, chemicals and nutrients. Whenever we use any chemicals and nutrients for agriculture, then those have to be approved by the competent authority. For various applications. So this is also true about drones, but in case of drone, the competent authority has already approved the use of chemicals and nutrients that we already use for the agriculture by other means. High initial cost is always the issue with the new technology, and this is also with the drone, because currently the cost of the drone for agriculture spraying along with all the attachment is up to 10 lakhs rupees. Connectivity is issue actually, because when we say that the drone is easy to operate, this means that we have to we should use the drone in an autonomous mode, and for that we need connectivity. Though we talk about no issue of the connectivity in the urban area, but when we are using the drones in the rural area, so that is a really issue in many pockets actually. But hopefully this will be solved in coming years. Land holding is major constraint. And then high tension electricity line and trees, because we know that our infrastructure development was not systematic, and so therefore there are high tension electric line in between, so we cannot use. The trees are also issue. Land holding means maybe there are many farmers who are having the land holding up to 1 hectare and using drones just for 1 hectare, and maybe with the several crops on the farm is really issue actually. Then another are certain institutional and capacity development issues related to training, then skill development, and certain regularity rules and regulations. But all these three issues, they are being addressed at the government level at a very high speed actually. There are several drone training institutes now which have been opened, and Mahatma, Phule, Krishi, Vidyapeeth, Rahuri is one such. And there are several universities who are organizing capacity development program, and the government has formed several committees to deal with the legislative and regulatory issue for use of agriculture in drones, and that is also being sorted out. And another thing is that the weather could be the issue actually, because when spraying is concerned, we cannot use drone in certain conditions. We have already prepared the standard operating procedure for that, for guidance to the farmers. But then we cannot use drone all around the day because anyways, we cannot perform spraying in rainy condition. But at the same time, if there is a high windy or high temperature, then maybe using drone is the limitation. But anyway, so these are the issues and challenges to us, and we are in a process of addressing all those things. As far as input application is concerned, spraying, then normally we use this type of the drone, which is quadcopter or hexacopter. So having 25 kg of the total load actually. Then with this kind of the drone, if we want to use this drone for the agricultural spraying, then there are 8 steps that we need to perform. First, we need to calibrate for GPS, then pre-flight checks, flight planning. I have shown pictorially as well here. GPS calibration, pre-flight checks. Then we have to perform the flight planning, that is mark the area and all those things. Then we have to fill the input, that is chemical and water. Then setting up the flight parameters in the sense that drone speed, then height of the drone above the canopy, and the sweat width and all those things. So once this is done, then drone is ready to fly. Then the drone will fly actually. And after the spraying is over, if we want to measure the efficiency of the drone spraying, then that also we can measure by installing certain water sensitive papers and by doing certain operations, measurement actually. So these are the 8 steps, though currently we find that, okay, so there are so many steps, but the experts, they don't really bother about this. Even if we do certain tractor operations, we have to perform these many steps. But with the drone also we have to perform, though it appears something clumsy at this time, but then when the experts, they have started using, they are quite well conversant with this. With all these 8 operations together, we can cover up to 10 acres of the area in 3.5 hours. That we have developed the protocol for this by using hexacopter drone, and cost of this drone spraying comes up to 400 to 500 rupees per acre actually. Then there are certain drone spraying operating parameters. So what should be the nozzle? What are the number of the nozzles on the spraying boom? Where to mount, whether those nozzles to be mounted below the motor, or whether those nozzles to be mounted on the boom. So all those things we have standardized, and based on this, we have also developed the standard operating procedure. So that involves the type of the nozzles, then number of the nozzles, then mounting of the nozzles, then discharge of the nozzles, then swath of the flying, then height of the drone above the crop canopy, and drone speed, and all those things. So a few of those drone operating parameters I have mentioned. The type of the nozzles need to be anti-drift flat fan. The nozzle discharge should be in a range of 0.3 to 0.6 liter per minute. Nozzle angle 60 to 120. We have to use 2 to 3 kg per centimeter square pressure. Nozzle can be placed on boom or below propeller. 4 to 6 nozzles are recommended. Swath is 3 to 6, and the droplet size is 150 to 50 micron. So in that way, flying speed should be in between 4.5 to 5 meters per second. Canopy height, above canopy drone height, drone should fly in general 1.5 to 2.5 meter, but there are certain crop varieties which are sensitive to lodging. Then we need to fly the drone at a higher elevation. Then water to be used is that for early stage, we can use 20 liters of the water per hectare. For development stage, we need to use 25 to 30 liters per hectare. So these are all the SOPs. Those have already been published, but in summary, I wanted to inform about these SOPs. And as far as environmental parameters are concerned, we advise that during summer season, we should operate drone from 6 a.m. to 10 a.m. and then during afternoon hours from 3 p.m. to 6 p.m. and during winter 8 to 11 and 2 p.m. to 5 p.m. So all those are standardized. And then temperature should be in the range of 30 to 40, not more than that. Humidity should be greater than 45 to 55. Wind speed should be in less than 3 to 3.5 meters per second. So this is very important as far as the efficient operations are concerned. Similarly, we can use the drone for different kinds of the mapping, which I have indicated here. Field application, crop yield, yield potential, NDVI, crop pattern, and all those things. And these are the several kinds of the camera, thermal sensor, 3D LiDAR sensors, hyperspectral imaging sensor that we can mount on the drone. Just like as there were 8 steps for using drones for spraying, there are 10 steps for using drones for the mapping, flight planning, setting up the flight. Then we have to need the magnetometric calibration, placing reflectance sheet, because whenever there is a camera, we have to have the certain target and reference. Then another flight parameters, they are similar, and after that we have to perform certain kind of the analysis as well once we get the drone image with the help of the drone. So these are in short the two applications. Then we need several kinds of the permissions for the drones. These are different for different types of the drone: nano, micro, small, medium, and large. But as far as the agriculture is concerned, we normally use the small drone, that is the drones having 2 kg to 25 kg weight. And then for that, we have to ensure that we are operating drone in green zone or yellow zone with permission. So that is available anyway by the government on the digital sky map. So that is available on website. So the drone should already be obtained with the typecast certificate by DGCA. Then the user should also obtain the unique identification number for the drone before flying. And the drone operator must have the drone flight license from the authorized RPTO, that is the Remote Pilot Training Organization, which is authorized by DGCA. So these are 4 kind of the permissions which we should know. And Mahatma Phule Krishi Vidyapeeth, Rahuri is the first agriculture university to be awarded with the Remote Pilot Training Organization by DGCA. So we are continuously training the farmers and the different participants on drone flying, and at the same time using drones for agriculture. And we also provide guidance to them how to obtain the typecast certificate UIN, and how to locate whether your farm is in green zone or yellow zone or red zone. I skip these slides. There are procedures for this purpose, but and then we have these kinds of the facility, as already told by our founders, of that we have 38 of different kinds of the drones for spraying, and we have simulators and other kind of the things to provide the training for the drone pilot actually. And then we can, besides this, we can use the drones for the several purposes. Mapping, we know that, and we are trying to develop certain AI-based systems wherein we can map the soil fertility and biotic and abiotic stresses with the help of drone. And based on this drone, we can you prepare the prescription map for the field, and we can decide the inputs to be applied. So there could be one mapping drone, there could be one inventory application drone, and we can also have integrated system where is mapping and inventory application drone is the same. So we are also working on this. We are also working on real-time irrigation management system using drones for the canal command area. We can also connect the drone with the tractor so that drone can prescribe the inputs to be applied, and tractor can apply the inputs at the variable rate. Then similarly, in real time, pest and disease identification system. So that is also one of the future perspective, and few things they are already going on this issue. So I think with this, I would like to remain. My time is up. Probably I might have taken 5 minutes or more. Sorry for this, but I would like to thank profusely the organizers, SAPI, for giving me the opportunity to brief a few things about this drone application in agriculture. It is quite vast and emerging subject. Then maybe if there are certain issues, difficulties, I'm very happy to discuss or interact with you anytime. Thank you very much.
Thank you, Professor Gorantiwar, for this very good presentation, which is elaborately explained. And I think very few of us have a direct concern or relations with the agriculture, and must have been a good, insightful presentation to us to know that how the technology is being used in the agriculture. You have mentioned about the mapping systems for the role for the drone as well as spraying, whereas in the future also what applications should happen. Good food for thought for all the participants of this webinar. Not only them, the YouTube will spread this knowledge far and wide, and I think it will go quite a lot. Your idea of using it in the hyperspectral farming is very wonderful, because this is where the area the India have to produce more in the same acreage, because of the growing population. As on date, we are the highest population nation in this world, and less land available for us. The only solution is to increase the productivity of the existing land available. So where is the drone using AI in agriculture? I think the mission of the government as well as of the farmers and the professors like you all will take us to a next level, and we'll be not only feeding this country alone, but the other countries too in the world. Thank you, Professor. Now we have General Narayanan's keynote speech on military drone. General Narayanan, brief about him. He's a distinguished soldier, commissioned in 1982, and an innovation-driven professional with 39 years of experience in technology, education, and R&D, MRO, and so many other things. He has long experience of heading technical institute, training institutes, basically, and has been imparting training in the field of engineering and management too. He has done various prestigious courses of the armed forces, including the senior command courses, higher defense management courses, and advanced professional program for public administration. He has served in all terrain, including the high altitude area in Northern and Eastern Command, and has got prestigious appointments also. He was BGS IS of the Corps in the Eastern Command, ADG EME, and Commandant Military College of EME. During his leadership, MCEME was awarded the prestigious Golden Peacock Award. It was also given Utkrisht Sansthan Vishkarma Award by AICTE, New Code of Education Award for Best Digital Practices and in the field of education. The most important part of, the characteristic what I would like to highlight here about General Narayanan is that He is the chief architect in demonstrating the offensive swarm drone concept. And it was demonstrated in 2021 Army Day Parade. This is where we feel in the SAPI, we feel that this is the template of his working on the concept and taking it, actualizing it on ground, working along with the startup in doing. This is where we should replicate this particular model in other areas too of the complex engineering, like I told about the aircraft, fighter jets and other weapons development, etc. And this is it is our endeavor also to spread this template everywhere. As I mentioned, he's an AVSM awarded by the President of India, and also he's the President of the Laser Class Association, as well as Vice President of the Yachting Association of India. Over to you, Jalan Narayanan, for your insightful presentation about the drones.
Good morning, ladies and gentlemen. First of all, I would like to thank Mr. Pradeep Gupta for this introduction. I think I'll start my topic. Thank you once again. Thanks a lot, Mr. Pradeep Gupta, for giving this opportunity of presenting on drones for military applications. I mean, a large number of the invitees who are here, you would be daily listening in the newspaper the drone warfare which is going on between Russia and Ukraine. Actually, the drones, when it started long back during World War I. But what formally took over was somewhere during the Gulf War in 1990. The US used the drones for basically recce and surveillance, and they were able to target, based on that, the Iraqi army. Second time the drones got, this combat drones which I'm talking, got used was during 2000, once the Taliban took over Afghanistan. That is the time the USA decided to use their drones for targeting leaders of the Afghan Taliban. And this continued till 2010, where they used the combat drones. And now they even did some strikes in Pakistan, where these Afghan leaders were holding out. They had done a large number of strikes in Yemen, Somalia, and Sudan also. 2019 was the first time when the combat drones were utilized by the insurgents, militant, terrorists, whatever you call them. They are the Houthis, who are supported by Iran. They used 19 drones to destroy the Saudi Arabia oil processing units, which were in Abu Ekekui and Kurmeis. These 19 drones came like a swarm, and this is the first time you can say that concept of swarm drones got introduced, and the Saudis' anti-aircraft gun could not actually even get one drone down. That was because they were all planning for, all their anti-aircraft were for aircrafts and missiles, and nothing was catered for drones, which are low-flying aircrafts. Come 2020, the 2020 started with a bang. On 3rd January, the USA targeted the Iranian General Soleimani. They used the MQ-9 Reaper. The General Soleimani was near the Iraqi airport, on way to meet the Prime Minister of Iraq, and he was targeted and killed. Again, MQ-9 Reaper was utilized. Then the same year started the Armenian-Azerbaijan war. Now, this was a very interesting war because previous war between this Armenian and Azerbaijan, the Armenian had won comprehensively against Azerbaijan. At this time, Azerbaijan won comprehensively against Armenia because of use of combat drones. The Azerbaijans used the Bayraktar drones of Turkey. This is a high-class drone which can fly in high altitude and can carry missiles. So it can fly up to 25,000 feet. You can say this is the first war which was entirely won on the strength of drone warfare. The Azerbaijan drones could take on and destroy about 150 tanks of Armenian army, 42 armored fighting vehicles, similar infantry combat vehicles, about 250 artillery guns, 65 anti-aircraft guns and missiles, about 16 radars, and about 250 trucks. Now, these data is there from the independent agency ORYX. I have not made up these data. They are all available on the internet. Compared to this, Azerbaijan lost only 1/6 of what Armenia lost. And Armenia had to surrender. The beauty of this war was another the way the Azerbaijan used the tactics also. They put back the drone on top at about 20,000 feet so that they are all not detected by the radar also. And then what they did was they modified their biplanes, which were, you can say DR biplanes, DR planes, or beyond economic or beyond local repair, those kind of, which are unserviceable planes. But they modified it, removed the engine, put the motor, and they made into a single, so sort of a single, not even without a pilot. It's like a UAV, and they launched 15, 20 of them towards the Armenians. So Armenians thought that this is the main attack which is coming up. So they opened up all their missiles, their radar, everything. Now this was caught on by the Bacter, which is on top. And the moment they opened up, the Bacter also opened up and destroyed all their radars and anti-aircraft. So the complete AD system of Armenian army actually got destroyed in this whole system. And that's why they lost the war very badly. So coming to the Russian-Ukraine war, which is going on. As you're aware that, Russia has got its own UAV, but they were not champions of UAV. If you can look at it, drones or UAV, whatever you call it, the champions are actually USA, Israel, Turkey. I mean, as on date. Now China has also come into the picture, and now Iran also has come into the picture. So Russia did not have such big UAV or drones with them which could destroy the enemy, but they were having a small Orlan 10 UAV, which used to do a recce missions and small bomblets which can kill soldiers. But now, after the drone warfare took on, where the Ukraine got the switchblades from the USA and the Bacter from the Turkey, and they did complete annihilation of large number of ammunition dumps of Russia. The Russia got hold of the Iranian Shabat 136. Now, Shabat 136 has got this ammunition on its nose. It can fly about 1,500 kilometers or more than that. So long distance it can cover. It can stay for more than 72 hours on the sky. So it's got a lot of advantage. And if it hits a building, that building gets destroyed. That's the kind of ammunition that is packed into that drone. So this Iranian drones has now created a lot of panic in Ukraine as large number of their buildings are getting destroyed. Their power stations are getting destroyed, and that their anti-aircraft gun has not been able to down the Shabat in a big way. You will be also knowing that the Ukraine actually had used these Bacter drones to kill that Russian warship called Moskova in somewhere in April 22. So that is the kind of technology they have used. Ukraine and Russia both are using in big numbers the Mavic drones, which have been made by China, but exported to different countries. They are buying it because the Chinese companies have refused to directly export to Russia and Ukraine. With this as the introduction, I'm going to cover my topics in following fashion. First, I will talk about the characteristics of drones. Then, of basically military drones. Then I will tell, Indian Army has got large number of arms and service, combat arms, combat support arms, and combat services like infantry, artillery, armored corps. Then you have logistics, ordnance, EME, and then you have communication people, signals, engineers. So I'm going to tell them what is the requirement of the drones in these arms and services. After that, I'm going to talk about swarm drones. Swarm drones is my pet subject because I have worked a lot in swarm drones. I'm going to tell you what we are looking for in swarm drones on you. In between, you talk about the difference between a loitering ammunition and a drone, because that's also important. We should not get confused between a loitering ammunition and a drone. Similar, but there's a big difference between them. And after I finish up the swarm drones, I will say what are the anti-drone technology which is available in the world as on date. With that, I'll end my presentation. Now, coming to the characteristics of military drones, you see, what is drone? Unmanned aerial vehicles are commonly called drones. They are like aircraft, but remotely controlled by operator on the ground. They can be a fixed wing or rotary. So like you have fixed wing aircraft or helicopter, these also can be a fixed wing, like an aeroplane, or it will be a rotary, like a quadcopter or hexacopter. Most drones are fitted with sensors and cameras to gather intelligence and conduct rescue mission. This used to be the initial stages where we did not fit any weapon system on drones. But today, drones are equipped with wide range of weapons, including missiles, bombs, and machine guns for conducting targeted strikes against enemy. Drones have very less radar cross-section, so they're very difficult to be detected by radars. Now, millimetric wave radars are under production, which can detect to some extent these radars, and there are various methods now to detect also. Moreover, they can also, but most of the countries do not have this kind of technology. So that's why still drones are very effective in warfare. Moreover, they can also fly at altitudes, making them more difficult to detect and intercept. Drones can fly for extended periods without the need for refueling, allowing them to conduct long-range missions. So the Bayraktar of Turkey can fly for 24 hours without refueling. When I say refueling, they don't have to come down. And for 24 hours, they can be in the sky. Similarly, the Shabbat of Iran can fly for more than 48 hours. Rotary drones are capable of taking off and landing vertically, which allows them to operate in areas where there is no suitable runway. Drones can also be used to disrupt enemy communication. But the problem with drones, they are vulnerable to jamming and other cyber attacks, and they have limited payload capacity. They cannot carry so much of load like an aircraft. Now I'm going to talk about the requirement of military drones for each arm and service, which I told you before. So we'll start with the drones for infantry. These are the headings, if you can see on the left side, which I'm talking about. There will be similar heading for other armed service, but other armed service will require for a different purpose. All will be requiring for recce, but it will be for recce of different things. That we should understand for what it is. So the kind of camera you will put on these drones will be different for the different arms and service, because some will require longer ranges, some will require shorter ranges. So reconnaissance, drone equipped camera and sensor can provide real-time intelligence and surveillance infantry units. A problem for infantry is what is behind the mountain. So now that can be seen what is there behind the mountain. So the situational awareness can be given to infantry. It can be used for targeting, for to use to guide precision airstrikes, or even artillery fire into enemy target. Reach supply of ammunitions, or any supply or medical equipment can be possible where a soldier cannot reach. You can send it through drones. Of course, to extend the communication, that also be drones could be used for as a relay station, and it can extend the communication. Now, these are not the four. Similarly, when I talk about others, they're not limited with this force. A commander, based on his knowledge and his requirement, he can use it for innumerable tasks, all these drones. And they have been done recently also. Coming to the artillery, for target acquisitions, they can do that. For artillery fire adjustment, they can see how the feedback is provided through the drones to the unit which is doing the firing, and see where the ammunition is landing, and they can correct it. And once they have fired and destroyed the enemy, battle damage assessment also can be done. And also these drones can be used by artillery for their own logistics to get the supplies or their ammunition. Mechanized forces, which includes the armored corps and the mechanized infantry, that is basically the tank people and the BMP people, I'll call it, to understand it basic level. Again, reconnaissance. Now, what is very difficult to find out? No, that also can be found out using drones. Plus, you can tie a drone, which is called a tethered drone, to a tank or a BMP, and take it 100-meter away, 100-meter height, and you can now look into the enemy territory to 6 to 7 kilometers, and continuously the drone gets powered through this tank or the BMP, and so it can stay on the sky for a very, very long time. Target acquisition is another thing which can be done. Force protection. Now, the problem with is when the mechanized forces move, there are mobile teams which are put by the enemy to target and delay these mechanized forces. So the drones can go ahead and find out about these hard-hitting mobile teams and missile teams and can neutralize them, or even provide information so that subsequently the infantry or other teams can go and neutralize them. Logistic support, again, same for everyone. It can provide supplies, ammunition, and other equipment. Communication as act as a mobile relay. Combat engineers for same as reconnaissance, but here the reconnaissance is like to identify obstacles or detect enemy position, and whatever the engineers require, the data that it can be provided through drones for them to make a breach or even to lay mine or whatever requirement. So mapping and surveying is another thing which these drones can be used. Even Professor Gorantiwar said about mapping. So here also they can be used for mapping, which will provide high resolution imagery. Demolition of bridges and other things which the engineers have to take on task, demolition tasks, that also can be done by using drones or even clear obstacles. Construction support, drones can be used to transport construction material and equipment to remote or hard to reach location. For Army Air Defense, again, these drones can provide the surveillance and to detect and track airborne threats. They can be used to monitor airspace, identify incoming aircraft or missiles, and provide the information to air defense units. They can also be used for targeting, so that this air defense, for the incoming threat which is coming, they can be targeted by the air defense people. Force protection, for again to detect which are the enemy is sending, what kind of a aircraft is sending. That early warning can be given to air defense units, and they will be able to respond in a much better fashion and engage the threat. Training and simulation, the drones can actually provide realistic training and simulation for air defense unit. They can simulate incoming threat and provide practice scenario for air defense. Signals versus communication, to extend the communication, act as mobile relay. Surveillance of enemy signals, enemy, what is it sending? Those can be surveyed using your EW equipment on a drone. You can also jam enemy communication signal using your drone by putting a jammer in your drone. And of course, for maintenance support also, it can be placed. Logistics, as we discussed, the transportation, it can be used for any material, surveillance and recce for the logistic purpose. As even when the logistics unit move, they should not, there should not be any hard-hitting teams of the enemy to take on the logistics, because logistics are not very well protected. Because if you cannot hold them, they have to move fast so that they can ensure that the supply reach to the forward troops at the earliest. So it is possible that the enemy can put some hard-hitting teams in between so that they can take on the logistics and delay the move. So these drones could be utilized for that also. Maintenance support is one, and delivery of all emergent supplies, ammunition, and everything. For maintenance people, I am from Core of EME, we are the maintenance people. It can be used for inspection of the equipment for damage, wear and tear by providing high resolution imagery and detailed information about the condition of the equipment. Very important. Otherwise, we have to send a team always to inspect to see the condition of the equipment. It can be used for monitoring equipment and for change in conditions. Can be used to carry tools and equipment to support maintenance operation. They can carry spare parts, tools. And if you get heavier drones, you should be able to carry engines, other things also. And this will make the maintenance much faster. Drones can also be used, fitted with the robotic arms or other tools to perform maintenance tasks on equipment or vehicles. So remote operations can also be possible. Medical, as you are all aware, medical supplies delivery can be done. It could be blood, it could be vaccine, it could be medicine, it could be anything which can use. And drones are being utilized in the civil sector also for large number of medical purpose, especially if there's earthquake, there's avalanche or anything. Large number of medical equipment are transported using drones. For emergency response, I said, it could be for any emergency response, it could be earthquake, it could be avalanche, it could be anything, or it could be ambush on an army convoy. So we can use the drones for ensuring that this medical kit reaches at the earliest. Surveillance and recce for medical purpose. And for diagnosis, also use the cameras and sensors to diagnose the condition of the man in the field, and so that they can send the imagery and the doctor can say what kind of support is need to be given. Now, once you have finished this, we will now talk about loitering ammunition. Now, what is loitering ammunition? Loitering ammunition is also a sort of a UAV that combine the characteristics of a guided missile and a drone. Now, there's a difference. There has to be a difference between a drone and a guided missile. Now, a drone, which is also called a kamikaze drone, is a loitering ammunition. Now, what is kamikaze? Kamikaze is a Japanese term which they brought out in the Second World War, where they said they will fill an aeroplane with large number of ammunition and go and destroy a ship by striking the plane against the ship. So it's a suicide mission. That's how it's called a kamikaze. So these kamikaze drones are also called a loitering ammunition. The difference between them and a guided missile is once a guided missile is fired, you can retrieve them back. You have to either destroy it while it's on a flight, or it will go and destroy whatever the mission was. Whereas the loitering ammunition can be called back and safely, and the mission can be aborted. So that is the biggest advantage. Now, these are the autonomous systems to loiter over a specific area, search for a target, and once the target is identified, the loitering ammunition attacks and destroys it either by diving into the target or by detonating an explosive payload over the target. They are small, lightweight, and portable, allowing them to be launched from either ground-based or airborne platforms, such as aircraft or helicopter, or even ground vehicle. They're also equipped like drones with a variety of sensors to detect and track targets. The biggest advantage of loitering ammunition is ability to provide military forces with a new form of precision strike capability that can neutralize enemy targets with minimum collateral damage. The last point, very important, minimum collateral damage. So this is a precision target it can take on, and it will loiter on the sky till it does not find its target. The moment it finds the target, it goes and hits. So what is the difference between loitering ammunition and a combat drone? So that is very important to understand. So in 3 columns, I have tried to explain. First is the criteria. Second, it talks about the loitering ammunition, and third is the combat drone. The first is the purpose of loitering ammunition is to engage and attack stationary or moving target. Whereas when it comes to combat drones, it is to provide real-time situational awareness, conduct surveillance, gather intelligence, and engage and attack targets. So combat drones, when it engages an attack target, need not destroy itself. It has got missiles fitted on it or bomb fitted on it for attacking and engaging targets. Flight time of loitering ammunition is up to several hours. It is supposed to last, at least because it is supposed to hover for a large amount of time till it detects a target. Whereas in a combat drones, mission is already pre-planned, so the flight time is shorter, typically an hour or 2 hour maximum. Launch and control, both loitering ammunition can be launched by individual soldier, and it can be controlled remotely. Whereas when it comes to combat drones, it is from a base or could be from a ship or from anywhere, but can also be controlled remotely. Target acquisition, generally same for both of them. Attack method, generally same, but when it comes to loitering ammunition, it will explode. When it comes to combat, it may explode, may not explode. It may drop a bomb. Payload, when it have a loitering ammunition, will have explosive, lethal, which is lethal. Whereas the combat drones will have explosive or non-lethal payloads also. Mobility, loitering ammunition can loiter or circle around the area waiting for a target. Whereas in a combat drones, it can fly over an area or move to a specific location. It will not be stationary, moving around in a circle for looking for a target. Cost of a loitering ammunition is relatively inexpensive compared to combat drones, whereas combat drones are more expensive. Human involvement in loitering ammunition is less. They can be also programmed to autonomously search for and attack targets, whereas in combat drones, more human intervention is required because you're doing surveillance, and based on what feedback you get, you take a decision. Mission flexibility, limited to attack and destroy mission. It is, whereas combat drones can be used for a variety of missions, including reconnaissance, surveillance, and attack. Loitering ammunition are more vulnerable to anti-aircraft fire due to longer flight times, whereas combat drones are more resilient to anti-aircraft fire because they can fly at a high altitude. After having seen the difference, now let us look at what is swarm of drones. I would like to tell you about swarm of drones because this is, as Dr. Pradeep Gupta said, we had actually, along with a startup new space agency of Bangalore, the Simulator Development Division had demonstrated the first offensive swarm of drones during January 21 Army Day Parade, which because this was to give an exposure to the senior army officers, what is a swarm drone and what are its capability. Based on this, large number of swarm drones procurement orders have been already issued by Army Headquarters, and some swarm drones have already got inducted in our army also. Now, what are swarm drones? Now, swarming is characterized by collective behavior of multiple agents. For agents, read drones towards achieving a common objective. So, a large number of drones having a common objective and should have a collective behavior. So if you look at it, one end of the swarming spectrum will be multiple agents maneuvering in space to form a cohesive group while navigating. So they have to navigate to go to a specific location, and they should move as a cohesive group. But in the other end of the spectrum will be that they have to collaborate between each other also. So they should have intelligent behavior, and they should be able to interact with each other so that whatever problems comes in between, they are able to solve those problems in a dynamic environment. So this is what makes a swarm drone actually. Now, you would have seen large number of drone show. I mean, any big event takes place, drone show takes place, and you know, we have large number of drones doing some miraculous things, some show off. Now, what is the difference between those military swarm and the drone show? When it comes to military swarm, the control there has, or the human and the loop is optional. You can launch the military swarm and it can go up to the objective, do its work and come back without human intervention. Whereas in a drone show, the complete show is centrally controlled by humans. Now, when it comes to space and time, when it comes to military swarms, it is on board. That is, the spatially and in time, the drones move based on the onboard processing which is available. Whereas in a drone show, it has got onboard processing, but every movement is pre-planned. Similarly, swarm intelligence is not required in drone show, whereas it is required for a military swarm. When it comes to autonomy, the military swarms are fully autonomous, whereas drone show are pre-planned. AI may be there in drone show, may not be there, but it is required in military swarm, and edge computing, that is, every drone will have its own edge computing. The drones, military swarms, collaboration is through networking. The drone show, the drones which are used may not be networked. Now, military swarms use distributed intelligence. What is distributed intelligence? Distributed intelligence is preferred in military swarm, where every agent or every drone has identical computational resources. That is the hardware and the software. They have to have built-in redundancy, where the surviving members keep collaborating as a swarm for mission continuation, thus bringing in robustness. So as they keep on moving, the collaboration has to continue. The individual drones need to be aware of the overall mission progress. So every drone should know what is the mission and what is the progress going on. Be capable of collecting and assimilating awareness of their local surroundings, including other drones, and finally be capable of collaborating with surviving swarm to achieve the mission objective. When you say the surviving swarm, it is possible that some of the drones, when they move as a swarm drone, some of them will get destroyed. So the remaining have to collaborate with each other so that they are able to achieve the mission objective. Such a collaborating agent will at times face a situation where for the sake of swarm survivability, it has to select a particular operation maneuver over another, which may be conflicting at that time. That is why the decision AI has been given, so it can take a decision. So the priority of individual agents will be first that it has to survive its own. Then it has to ensure that it is collaborate and have cohesion with other swarms. And third and final, it should be able to update the mission parameters. Now let us see what are the swarming strategies. Now, when we actually ask for swarm drones, these are the 3 swarming strategies we check on the swarm drones. So if you satisfy these three, flocking, schooling, and foraging, then only we consider that the drones supplied or which has come for trials are fit for swarming. Now, what are these three? Very important. Basically, for the startups, it is very important. First comes to the swarming. Now, the drones, this is the first phase of operation when the swarm gets airborne and is launched. Now, as you are aware, each of these drones could be launched from one place or it could be launched from various places due to constraint of space or camouflage constraints. So when they are launched from a different location, these drones need to come together as a flock before embarking on a mission. So they have to come together. Now, when they come together, they have to ensure that they demonstrate cohesion and dispersion. Now, what is cohesion and dispersion? Now, if you see on the right side, I put two diagrams. So these three drones, they are doing cohesion. But the fourth drone is very far away, so it's not cohesion. So it should not be that far away also that it cannot communicate with other three drones. So it has to maintain this cohesion. Similarly, it can't be too close so that they start destroying each other or they are not able to go in a pre-planned way. So hence, they have to ensure that these drones have proper cohesion and dispersion so that they maintain a safe distance and avoid collision between them. And during flocking, no operator intervention should be required. They should be able to, like the birds flock together, like this drone should be also flock together. The pattern of flocking should not get repeated in exactly same fashion, as it means the drones are pre-planned and decisions are not on the go. Irrespective of how they are distributed at any given point of time, they have to aggregate and form a tight group when in flock mode. So these are the points which we check that whether the swarm drones is fit for flocking or not. Second, which is coming is the schooling. Schooling is basically once the drones are flocked, when they have to go from one place to the point where the target is, that movement is called schooling. So on completion of this flocking phase, the swarm runs down the available resources, that is how many are available, against the mission objective and launches the next phase. This is called schooling. The swarm maneuvers from the launch area to the first rendezvous. They have to demonstrate goal seeking while ensuring cohesion and dispersion. So now if you look at this diagram which is below, now if you see there are 5 drones, 1, 2, 3, 4, 5. They are going to another location, which is the rendezvous, and they can take any path. They can take any path. Straight lines are not preferred, is because if they move in a straight line, that means they are actually not going, they are pre-planned. So we are not looking at pre-planned. They are looking at swarm where they can take a decision on the go. So they should be able to disperse and still maintain cohesion and go to the another area. And from there, so this is variable intra-swarm alignment. And from there, go to the final, its destination where the target is. So for doing this, they need to adapt to the environment in this phase, especially in view of hostile electromagnetic surveillance, ground action, or terrain concentration. So it is possible that some of them get jammed. So they have to take actions. They have to ensure that they collaborate and still reach that area and reach on top of the target. Now, if you look at the straight line movement, wherever there it is, the indicator agents are not reacting to each other activity. So because that is pre-planned is what we say. So that is not preferred. Coming to foraging. Foraging is the target area. Now, once the swarm reaches the target area, it has to operate with the elasticity to map the area of interest to sift out the target of interest. Now, at T0, the schooling mode, it is there. Now it is reaching the target area. This colored square is the target area. So these drones divide themselves for this target area so that it can map the area. So drone number 1 is mapping this brown patch. Drone number 2 mapping this yellow patch, and similar 3, 4, 5 is mapping the target area. So once this target area gets mapped, now the drone will send back or through their own intelligence find out through the map which all enemy equipment is there in this mapping area, and based on that, suitable action will be taken. Now, what we do, we check that whether you are able to do foraging or not. We will recall, say, number 2 and 4. We will say they have crashed, or these drones will be recalled back. So once they are recalled back, the balance 3 drones have to remap themselves and still cover the entire area, and forage area has to be done now freshly, where the area is given to the balance 3 drones. So this is called the foraging. So the swarming agents have to react to change in team size and cater to elements which have become unserviceable. There are large number of algorithms which are used. There are AND and B. These are the 2 which is the famous algorithms which are used. But we are not looking at what algorithms you use. We say that any algorithm will do, provided it is able to do the job. Now, after we finish with the swarm of drones, now let us see what are the anti-drone technology which are there in the world. First is the radio frequency jamming. This technology works by disrupting the communication between the drone and its controller. So the drone will either land or return to the point of origin, so it won't be able to do its task. Second is GPS spoofing. So in this, the false GPS signals are created. So this tricks the drones into believing that it is somewhere else. So once it sees it is somewhere else, it is not able to do its job, what it is meant for, because it has already gone to some other location. Acoustic detection. This uses a microphone to detect sound of drones. So this allows the security person to locate and track them. Very basic method of detecting drone. Laser-based systems. This has been developed by DRDO also, where we can disable the drone by damaging the sensor or electronic by firing laser-based gun system developed by DRDO, but it is one of the most preferred options for being anti-drone operation. Net guns. This uses a gun that fires a net to trap the drone midair, causing it to crash. Drone detection radar, which I said that now the technology has come where millimetric waves are used to detect drones by using radar systems specifically to detect small aerial vehicles. Now you can, once you detect, you're able to damage them. Drone catchers, they can, you send a larger drone with a net. So this larger drone will go near the smaller drone and put the net over the smaller drone and make it crash. Drone eagles, this you can use the eagles to bring down drones. This also we had practiced during our demonstration. We have a remote and veterinary corps, which has got a center in Meerut, and there they are training the eagles for catching or destroying the drones. With this, the preferred option, I will put it again, will be which the Indian Army is looking for is RF jamming and laser-based systems. So if any of the startups is interested, they can actually contact the Army Technology Board for these 2 systems. With this, I finish my presentation. If there are any questions, I'm ready to take them. Thank you.
Thank you, General Narayanan, for this very insightful presentation you have made. None of us had seen the Army application so deeply, what you elaborated, especially the swarm thing and the loitering ammunition, because these two things we keep on hearing quite a lot. Your presentation has very well explained the major role of the drone in reconnaissance, targeting, in communication, force protection also. The role in the artillery, infantry, mechanized forces, combat engineers, air defense, so many other areas too. So this is, I feel that will go a long way for our viewers, and there are some startups also in this today's webinar. They connected with me. I'll invite Mr. Kishan Tewari. He's the CEO of TSAW Drone, which is the first logistics drone company in India. They have got a very large operation. They are based at IIT Delhi Research and Innovation Center. So I'll request Kishan Tewari.
Good afternoon, sir. Good afternoon, everyone. So thank you, Narayan, sir. It was a wonderful presentation with details on how the drones work for military.
Kishan joined slightly late. He, I think, missed the agriculture thing, but nevertheless, you tell your problems, what you are seeing.
Yeah. So I joined a bit late, sir. So what we are doing, sir? I'll just start with a brief intro about us, what we are doing. So, sir, we are TSAW drones, TSAW drones, based out of IIT Delhi Research Park, which is built similar to IIT Madras Research Park, where we are building drones, automating them towards level 5. We are one of the very first startup in the country which is working on actually drone logistics for commercial use case, specifically for medicine delivery. So actually, we started with the medicine from the sky project that happened during this medicine from the sky happened during COVID second wave, partnered with World Economic Forum and Telangana government. So we were there. From there, we have been working on. So right now, we have two route deployment. One is in Telangana, in Nizamabad, connecting around 21 cities in a circle of around 50 kilometer. Then we have another route operational in Kolkata. In Kolkata, we are actually operating inside the city in yellow zone. So this is a tricky operation which we are doing with real-time coordination with local ATC, air traffic controller, and with guidance from DGCA. So these are the two routes we are operating now. We are opening up some few routes connecting Meerut, Noida, and other routes, other typical routes. So the main demand for the industry is to deliver medicine with a reduced time. So initially, for example, let's say if a medicine took around 7 to 8 hours to be delivered from customer to lab. Now with these drones, it will be delivered within few hours, like within 2 to 3 hours. Like we are now coming up with some use cases in Uttarakhand and Himachal. So Uttarakhand has a typical issue with the geography. Like let's connect about Dehradun to Uttarkashi. So by road, it's around 7 hours. With our deployment, which will be soon, it will be reduced to 40 minutes. So these are the networks. So what we are trying to do, we are trying to build a network across the whole state, and then using these as an alternate mode of transportation. So there are conventionally four modes of transportation: road, railways, airways, waterways. So this is the fifth mode we are envisioning as drones. Yeah. So this is what we are doing, sir. A bit about it, and thank you for the opportunity to introduce. Yeah.
So now I'll thank you, Kishan, for highlighting, and they had been sharing so many other problems, but I'll just mention in the question answer. I would now invite the Q&A. If anybody has the questions, we'll welcome and request the speakers to take these questions.
So may I intercept Pradeep here? Because I have got some questions in the chat box.
Yes.
So one is actually they are addressed to General Narayanan and Professor Gorantiwar. Sir, first is for General Saab. Sir, this is from Mr. Alok Dev. And may I request Mr. Alok Dev, you have some question on future development of swarm drones.
Yes, yes, ma'am. Good morning. This is a question to General Narayanan. And one was very enthused to see the entire presentation from a hands-on practitioner. So my question to you is just one, that when you're speaking about swarm drones and you explained the methodology through which swarm drones operate, one is given to understand that today swarm drones are also developing in a manner that out of the swarm, one element of the swarm is looking at reconnaissance, one element is looking at something else, one element is looking at targeting that particular thing, in the sense that while the swarm is autonomous and it has a mother, but the algorithms are such that simultaneously you can do 3 or 4 things together. So could you throw some further light on this?
Absolutely. These are called the heterogeneous swarms, where you have various types of drones, and they all operate together, but their roles are different. So this is already there. It is not a new thing. Actually, what we demonstrated in January 21 was a heterogeneous swarm only, where we used even kamikaze drones. Some, the swarm will have some kamikaze, where some will be doing recce and observation, some will be firing missiles, some will be dropping bombs. So you can have any amount. So the question is how you pre-plan that. Now, what thing is going to be future of swarm? Future of swarm is going to be depend on how much can you extract out of it. So it's going to depend on the AI. How strong is going to be AI? How strong is you going to be, recognizing your cameras, how good your cameras are going to be, where you can pinpoint every object which is there on the ground. If you can take on everything very clearly and your cameras are damn good, your AI is damn good, then sky is the limit what SOM can do.
Thank you very much.
Thank you, sir. Ladies and gentlemen, if you have more questions, then please either direct them to me in the chat box, or you can just unmute your mic and tell us that if you want to know a question.
Yes, I have a question for Gen Narayanan. One question regarding the anti-drone thing. Every day you see drones traveling from Pakistan, creating nuisance, dropping the steel bullets which were used in the Pooch operations were also being told that it was delivered from Pakistan side. So, and our security forces, the army and the BSF, they are the two major security forces operating on Indo-Pakistan border, especially the Kashmir, Jammu region. So they are more or less helpless. Yes, they have shot down, but then large number of drones are coming and dropping things. Drugs also they are dropping. So what is the should be done to stop all this?
You see, the biggest advantage of drones is, first of all, radars can't detect it, which I said. So all these radar which are put along borders are, they cannot detect these drones. So you cannot have 24 hours, man looking at the sky, waiting for a drone to come. So drone will come. And that is the beauty of the swarm of drones is not only one will come, the thousands will come, and you can take down only few of them. Balance will do their job and go back. Whereas individual drones will come, so they'll keep on dropping. So what we require is, at every location, we need drone detectors. But there will be thousands and thousands of drone detectors which will be required, so that as a drone enters, after all, these drones are emitting some signals. So they're emitting some EM waves. After all, they're in touch with their controllers. So when they're detecting these EM waves, but unfortunately, the distance which they emit is not much. When these border drones come, their main travel is not more than 5 to 10 kilometers, because their aim is they don't come deep into the territory. They just cross the border and they have their people elements who will pick up the package. So it will just throw deep inside the territory, about 4 to 5 kilometers. It will come, drop the package and go back, so that can be picked up by someone. Now, to detect these drones, we need large number of equipment which can detect these RF signals. Now, that kind of proliferation of equipment will be very difficult. It will be very costly, because these drones can come from anywhere. So what is important is this border outpost which we have people, they have to have drone killers by which they can either kill the drone through their firing method or have something laser-based to get these drones stopped. But these will, that's the beauty of drones. Till we do not have millimetric radar drones, radars at every border outpost, you will not be able to know a drone is entering or not entering.
Thank you, sir.
So the cost is too high of having this protection system.
After all, these drones cannot come and drop. Even if it drops one bomb or two bombs, it will hardly have any effect. It is not going to come and drop a nuclear bomb that it is going to, So that is why, you can't put so much of money into this just to detect, because he's coming on dropping one or weapon, some drugs he's supplying. For that you can't put, so much of pumping so much of technology to detect these drones. If you look at it, the Israel and the Hamas war, Hamas keeps on firing the rockets. For them, it is a low technology, whereas Israel uses all its gambit to ensure that they take on the rocket, they destroy the rocket. For a rocket of $2,000 of Hamas, the Israeli cost is $1 million to protect themselves. For a $2,000 rocket, which Hamas fires, Israelis spend $1 million to protect from that one rocket. Hamas fires thousands of rockets. So this is the problem. So if you have that kind of money, because Hamas can damage, whereas these drones cannot damage much as on date. And if it is a continuous process, And if they are damaging us, then do a beautiful, good strike on Pakistan and destroy the country. I mean, after that, no drones will come from there. So that is another way of looking at it. But what I'm trying to say that technology is there to detect these drones, but you have to cover the complete border, which is very difficult.
We have amongst us Mr. Sahani, who's a strategic affairs expert, and he'll appreciate that now Pakistan is waging the low-cost war with us, with sending terrorists. This has further reduced the cost for them, the drones, and increased the cost for us.
No, but
this factor can be examined by the strategic affairs expert, that the multiplying factor for them, for our enemies, because Pooch, if it is very startling that the steel bullets, if it is correct, were transported by drone from across the border. So many other things might have will be used in future. So it is very heavy cost on us, while low cost on them. If Mr. Sahni is there, I would request your views on this.
Look, we are talking about evolving technologies, and there will always be a certain advantage to those who start using these at an initial stage. The drone cost is low at this juncture, and the preventive measures are extremely underdeveloped as far as India is concerned. Our basic idea of countering drones right now is to shoot at them. Which is what we are doing with a large number of drones are down every month almost. We find a number of drones coming down. But technical solutions are available. They will have a certain cost, but I am afraid they will have to be adopted. They will not have just a single, shall we say, advantage once they are adopted. They will provide a multiplicity of other advantages, because once you put up sensors, once you put up these signal detection systems, they will prevent a whole range of other interventions by the adversary as well. Also, you must understand that we have what is often been described as the technology treadmill. You have to keep running to stay even in the same place. So this whole idea that, Pakistan has taken advantage, we have failed, I think it reflects a certain lack of strategic perspective on the part of our leaders. It reflects a certain ignorance of technology, where in the decision-making nodes. This is very, very important. We have got excellent scientists, we have got excellent people in our institutions, but the institutional integration of the technology sector with the governance sector is very poor. It is not something that is only in the sphere of drones. The degree of computerization in governance, the degree of, shall we say, creation of databases in the whole range of security. We keep talking about CCTNS. CCTNS today, the Crime and Criminal Tracking Network and System, today is at a level of function that the US systems were in the 60s and the 70s. And this is not because we don't have the scientific capabilities. We are launching spacecraft for European countries. So we have the people. The problem is the integration of our scientific establishment with governance and with the strategic sector. Now, strategic sector, if it exists, we have analysts, we have got certain institutions, but we do not have a national strategy on anything. As far as security, we do not have a national security strategy. We do not have a national defense strategy. The Army may have a defense doctrine. The Air Force may have a certain, or a Navy has a doctrine. But again, I ask a very basic question. To what extent has the Army or naval doctrine or the air doctrine been absorbed by the political and bureaucratic executive, which is the policy making body? The Army does not play any role in policy in India, which is one of the extraordinary characteristics across the world. In fact, I think there will be a very rare country where the national security advisor or the defense minister does not come from a military background or from a security background. So unless we address these more basic issues, you will find a disadvantage almost in every sphere. And you will find an adversary who is far more committed to his, hostility to India, taking advantage of every new stream. While we keep lagging behind, keep talking about issues that are essentially, I would suggest, at least a few years behind what is the cutting edge of technology today. Thank you very much for the opportunity.
Thank you, sir, for this insightful. Professor Gorantiwar has come, I think. Sangeeta, you can ask. Professor Gorantiwar.
Yeah, please, sorry that I had to leave for some time.
No, you can tell the question.
Here is a question, sir.
Okay.
There was a recent, research study published from Tel Aviv University, where, sir, they had recorded the sounds of plants when in distress, like they were dehydrated. And they used, sir, ultrasonic microphones, sir. So apparently they make noise when they are dehydrating or they are in distress. However, their sound cannot be heard by human ear because sound ranges, from 40 kilohertz up to 80. And we are not capable. Our ears cannot hear that sound, sir. So, sir, are you doing anything in that direction?
Really not related to this thing, actually. Relating the strays with the sound we didn't do, but I think that is a nice idea. So we currently observe hyperspectral response, which anyway is related to biotic and abiotic stresses, actually. Okay, but anyway, so this could be a researchable issue. So we will review the literature on this and maybe we'll plan then. Okay, so if it is feasible. Okay, but anyway, there is good relationship between this spectral signatures and what we call as stresses of the different kinds.
Yeah. Thank you, sir. Thank you very much, sir.
Thank you. Any other question? If not, we'll just conclude. And
there is one more question, Pradeep. Okay. This is from Mr. Ashok. Ashokji, would you?
Yes, ma'am. My question is to General Narayanan and Captain Ashok here. Just wanted to understand what are the hardware imports still going on in terms of drones? Are we having indigenous flight controllers and BLDC motors? Because in the market, it's heard that this is always a challenge.
You see, first of all, where the flight controls are still imported, everything is imported. We are still not started making flight controllers. And BLDC motor, no, because you require the rare earth metal for making those magnets. And we are still importing that. All this rare earth magnets based on neodymium and all is still being imported. So if you are saying assembly, yes, some people have started doing it, but as on date, both are nil. I'll pick that.
And sir, since you are from the EME, I still feel that these cutting edge technologies, they should be seeded right at the inception of the training. And are people still like it's considered as something very niche and beyond? But I would think that, do you think that these things should be introduced as a part of curriculum, which should be ever evolving right from the time people get inducted in the forces?
See, this cutting edge technologies, like I'll put it that way, which I call the technology which, ramp up things like AI, robotics. These kind of technology we have already introduced in our curriculum so that people are clear about this, and we give them small projects on robotics. For that matter, we even give projects where you can make, small drones, effective drones. You can make a fixed wing drone. Those kind of projects are being given to our student officers. So this disruptive technology, which I call them, are being taught in our colleges. But you see, with your first question again, that was a policy decision. When something is coming cheap from China, why should we make it? So that's why today there's a huge disparity between what we export to China and what we import. We export only 17 to 18 billion, whereas we are importing more than 100 billion from China. So there's a big balance of trade difference between us and China. So that was the concept. But suddenly that concept is now changing. And we are saying, no, we should have the technology with us. Even if it is initially costly, let's make this technology in India. So, fab are being established so that we can make our own semiconductor chips. So maybe in 5 years, we will be able to develop some of these things. But as on date, we don't have. But I'm sure the government is changing its policy. It is like we never made roads in our border so that China could not come in. But this government has changed the policy and made roads in the border. So that kind of a policy change has to be there, which this government has implemented. But everything, technology takes time for it to be developed. It is not that overnight we can make it. But in another 5 years, I'm sure these technologies will be made in India only.
Thank you, sir. And one last question is regarding drones coming from Pakistan. So definitely, these are very difficult. But then this is how the war is getting evolved. Like I had done, means earlier, nobody was thinking that the drone will take out a tank in the operation. And it has started now. This is how Americans have been humbled by Vietnam, even Taliban. So India shouldn't be thinking that we are down in technology or our technology is 60s, what Americans had in 60s. It is like, how do we evolve ourselves or innovate ourselves and do this? Because I was privy to Iran's development, which has happened in drones. There are hundreds of people in India who have helped Iranians in developing their drones. And their drones are now actually helping Russians to do that. So similarly, we will also have to look at whatever we have so that we can humble at least two of our people, which is China and Pakistan. Other than every day we get bled by them, by now they are sending drones. So what about IR sensors and thermal sensors if we put across the border? Can't they sense it along with the BPOs which are there?
See, again, your IR sensors, what will be the range? So yeah, unless these drones are within their flying range, their range, then only it will detect. The first few drones will get detected, they'll come to know because IR will be detected. And after that, drone will fly in such a fashion that they cannot be detected.
Okay, sir. Right, so sir. Thank you so much.
See, the
Thank
point
you,
is,
Captain Ashok.
this low technology drones will come. So now it is only manual, you can take it on. Not that the technology is not available. The technology available is very costly to take out a drone, which cannot do much damage as on date. When it comes to war, I'm not talking about drones like backup drones. I'm talking about these low-end drones which are available commercially, which are utilized for 2 kg, 3 kg drones which can drop small things. They are not going to do big damage to India, so need not worry in that way at all.
Captain Ashok, very insightful and very interesting questions and comments. And thank you, sir. Thank you, sir. Thank you. Lovely.
Okay. Thank you.
We had a very insightful deliberations today, and a lot of food for thought have been generated in this today's discussion by Professor Gorantiwar, by Lt Gen Narayanan, our strategic affairs expert Sani Saab, and others too. I'm very hopeful that today's food for thought, like for the anti-drone thing, the logistics, what Kishan has told, and also Professor Gorantiwar has mentioned about the agriculture. These will be picked up by the participants are there today, but then we'll be also putting up a YouTube. And I've been getting feedbacks about the issues what we have been highlighting. So it may go a long way in finding solutions to the problems raised today. Last, because it's already almost reaching 2 hours, I want to thank Lt Gen Narayanan for giving the keynote speech today in military drones, Professor Gorantiwar for agriculture thing, Mr. Ramchandru, who had been our boss in Defense Ministry. He's an IAS officer of Andhra Pradesh cadre. He's also joined. Mr. Ajay Sani, strategic affairs expert. Lieutenant General Matharu is there already, and Major General Ashok Kumar. Professor Bimal Roy, he had to just leave for some work. Mr. Nalin Kohli, who is the president of Association of Small and Medium and Knowledge Industries, which is doing wonderful work for the small industries, especially involved in knowledge domain. Mr. Pankaj Chaturvedi, who had been my boss, and so many other dignitaries who have participated in today's deliberations. I thank you all for joining this and making this webinar very successful. Thank you. Thank you.
Thank you. Thank you.